what was that?
Pressure.
Okay.
I'm going to start with
Yeah, we did the first one together, right?
Yeah.
So we started here. Now, again, remember in a hyperbola, it's the one that comes first. The term that comes first is your transversal axis. God bless you. Think about it, subtract. It matters what order you subtract in. So the guy that comes first makes a difference. So therefore, we're going to transverse off your x-axis. Your vertices and your foci go off the transversal of the x-axis. So now, find A and B don't change, A, B, and use your Pythagorean theorem, find C. And you can almost kind of see your triangle right here. We mapped out a triangle for you. You went up 5 over 12, and there is your 13 right in there. Excuse me. So now, find your center negative 3, 2, and find your foci and your vertices horizontally off of that. Add it to your x value, or your h of your center. Then, I need these co-vertices, but we really don't have to call them a co-vertice because they don't exist on your hyperbola, but they help us make a rectangle. So go up 5, down 5. Now, because these numbers were large, you didn't have to think 12 spaces over. Just kind of estimate, and then estimate what 5 would be in relationship to 12. Okay, so then you're left with finding your asymptotes. Asymptotes are the equations of a line. A line does not have a square in it. But start with this and this. Put the y here, put the x here. All you have to do then is find the slope. The slope, remember, is the change in y over the change in x. Is your y denominator over your x denominator square roots.
For the asymptote equation, is it always y is first and x is last?
Yep, because it's a y equal line.
So
You're gonna always set it up like this. Off of your y equals mx plus b line. Now, when we start with the y, we bring the y down. When we use the x, the b comes after from here. When we add and subtract to get y equals.
So it's always b over a.
No, remember, a and b don't change. What changes is your y and your x. It's always changed. Slope is always y over x. So wherever your y is, in this case, yes, it's b over a. But if my y was first, then it would be a over b. So be careful. Always remember it. I never use a and b because it's very confusing. Always use y and x because your slope doesn't change. It's always y over x. Okay? Questions?
How do we go from vertices? Like once you hit the center, what are we? I know we're changing the x-axis, but what are we adding to it?
A.
Is A?
Well, yeah,
Okay.
A. Because this is your main person, the one that comes first. Your
Okay.
main term. So A is always underneath the main one.
And then if we're changing the y, we're going to add A as well to the y?
If it was the y first, yes.
Okay.
Yes. Because in an ellipse, it matters which number is larger. That's where we determine A and B. But in a hyperbola, we determine which is the major axis by the one that comes first, the term that's first. Because associative property, we have no other way to know. You can put the x or the y first in your ellipse, right? It's who's the bigger one. Right? This next one, you have no terms to complete, no complete the square. So all you had to do was divide by 6 and get it equal to 1. And because you had nothing to complete, your center is at 0, 0. This is really how you see your asymptotes the best, when it goes through the 0, 0. So the guy that comes first, the term first, is the x, which means we're going to transverse off the x. That means this is the a squared, this is the b squared. And yeah, you end up with all radicals in this, but that's okay, because you're really working off your 0, 0. So here you are off your 0, 0. You're going to transverse off the x. You're going to go a, which is radical 3. So 1.7, 1.7. It really doesn't matter because you're just going to go 0 plus or minus radical 3. There's your vertices at the 0. So therefore, I don't really need the 0. So plus or minus radical 3, 0. There's your vertices. Your foci follow the same thing as your vertices do because they have to be on that transversal. Your foci is plus or minus radical 5. So just change this radical 3 to a radical 5. So plus or minus radical 5, 0. There's your foci. And your covertice doesn't really exist on your hyperbola. However, we needed to make a rectangle, so we go up and down radical 2. This is very, very close to getting a square. 1.7 and 1.4, which are approximately your radicals, are very close. So we send this through. Now watch, this is where your equation for your asymptotes come from. In this situation, everything is 0. So I have no y minus anything, no x minus anything, and this guy's gone. Your slope says change in y over change in x. So your y denominator is radical 2 over radical 3. That's this line right here. This line is just a negative slope line. See it? It's just the equation of a line. Now what's nice is graphing the hyperbola on your calculator is tough. However, graphing the asymptote is nice, and then you can see if it intersects at your center. And you know you have your asymptotes right.
Are we learning something later, or are we still going to go over this?
Well, we're just going to make equations of the hyperbolas like we did with the ellipses. Remember how we did the equations of ellipses? We're going to do, and you guys did like that, remember?
Didn't?
Did. You did.
Wait.
You did like them.
How come it's in zero, zero?
Because look at the x and the y.
There's no x terms and y terms by itself.
When you think x squared,
X minus 0 squared, y minus 0 squared.
and how do you know how much you go up? Like,
You look at the first term, that's x, so you're going horizontally. That's a squared, take the square root of this. So radical 3. So you go over radical 3, over radical 3. Just kind of estimate, radical 3 is like 1.7, so you know you're not all the way over here.
and for the y, you go up and
Up.
down radical 2?
Radical 2, which is like 1.4. You're only giving a sketch for, you know, just to see where you land. This one was a little tougher. I'm going to walk through the setup with you. So let's group our x's together.
Can you make it bigger?
I'm going to write it. We group our x's and then group your y's together. What do you do with 18?
Because my own 18.
Good. Okay, now, you're going to have to complete the square. Before you can complete the square, the coefficient of your square term has to be positive 1. So I'm going to have to factor out a 9 plus something, right? And I need this one also to be positive 1. So what am I going to factor out? I'm just going to write the negative 1. Now, also, your hyperbola is a minus, so that's got to be where your minus is. Y squared plus 6y plus something equals negative 18 plus something plus something. So I have to kind of write that aside. So what's half of negative 4? So x minus 2 squared, and what's 2 squared? 4. But bring this out, good, bring it out. Minus, what's half of 6? 3. And what's 3 squared? 9. Up times a negative 1, negative 9. Don't forget to bring this 9 down, and we really don't have to bring that 1 if you wanted to. So this is equal to 9. Add them all up. It's equal to 9. You need your hyperbola to be equal to 1. So divide everything by 9. Keep the 1 in the bottom, the denominator. And there you are. So you've got a center at 2, negative 3. This is your a squared. This is your b squared. Which axis are you transversing off of? Look again. Which one comes first? X. In a hyperbola, it's whoever comes first. Because in a subtract, it matters who is first when you subtract. So it's going this way. It's going to go over 1. There's my center. 2, negative 3. I make my axis like this. I'm going to go over 1. Over 1. Then over square root of 9 is 3. Up 3. Down 3. And I make my rectangle. And send my asymptotes through here. And they're going to come off of here. I find C by my formula, by Pythagorean's formula. Radical 10. So your vertex are changing horizontally. You add and subtract from your x value, which is your h of your center. If you're going vertically, you're add and subtract off your y. But we're only going horizontally. And you don't have to find a covertice. You just have to map it out so we can figure this out. Your asymptotes, guys, again, start like this. Take the y plus 3. Easiest way to start. Here's your x guy. X minus 2. Easiest way. Slope is the change in y over the change in x. Square root of the y denominator over square root of the x denominator. So keep this plus or minus, look at your y, take the square root 3 over 1, 3. There you go. God bless you. And now just get rid of this. The asymptotes. You thought what? Change in y over change in x. That's your slope. Rise over run.
X is 1, so you
X is 1. I didn't put 3 over 1. Now, it doesn't matter if you put this negative 3 up front or behind it. That's up to you. I usually just do it up front so I don't lose it somewhere.
And so, we're adding square root of 10.
Horizontally to the h value of this guy, which is 2. Now you can leave it as 2 plus or minus, where did I put my cosine? 2 plus or minus radical 10, because you can't resolve that any more than that. When we do this, 2 plus or minus 1, that you can resolve. But the 2 plus or minus radical 10, you can leave like that.
So the vertices are where the asymptotes and the of the square root of meet, right? So where the vertices would be right there, right before the both.
Right before the both sides. Okay. Okay. This one, once you completed your square, it was equal to 0. There was nothing we could do with this. It doesn't make anything for us. It has to be equal to 1, or a number that we can divide by to get it equal to 1.
I've got like no real.
Yeah, no solution. No solution, no hyperbola.
And since it's squared, you have to do it in fun square, right?
Yes, you had to take this, you had to find the squares. The part that usually messes up is this part right here. You have to take out the negative 9. Well, the 9 wasn't so bad. It's when we have a negative y that everybody forgets the negative 1. Remember, your hyperbola is having a subtract in the middle, so you got to get that negative out to the middle. Such as this one, you did it with the x down here. When you did these two, you had to take out a negative 1. Because you had to make this guy be a negative in the middle, a subtract.
That last number in red, what is it?
Negative 81. Because you're taking this times that. And it ended up to be 0. Couldn't do it. I think what happens probably the book might have had a misprint. They might have had a misprint here. Maybe they meant this to be 81. I don't know. Maybe there was a misprint, but it's not doable. Okay, again, this one, the last one, again, you're going to order your x's and your y's together. Try to follow where the subtraction goes. Your x is your negative x squared, so put that one second. If you did put it first, and that term became negative, you have to switch the terms. And remember that. The subtract has to be in the middle for your hyperbola. Like we did yesterday. Remember we did yesterday and we divided by a negative, it forced us to switch the order. This one also, you just have to reduce that. And reduce this one. But when you add and subtract them, you can leave it like that. Okay? You guys good with this? Questions? Nobody has a question about this one. Probably the hardest one. Sure. Okay, so let's put your y's first. And then your x's. Oops. And I'm going to move the 62 to the other side, okay? Complete the square. So take out a 9. Take out a negative 1. You don't have to say 1, but just make sure you switch the signs. And this is equal to negative 62 plus something, plus something. So what's half of 6? 3. So y plus 3 squared. What's 3 squared? 9. To get it out of here, 9 times 9, 81. So bring your 9 down in front of it. Then we've got a minus. What's half of negative 2? Negative 1. And what's 1 squared? 1. But remember, distribute this guy. What's negative 1 times 1? Negative 1. So you've got a negative 63 and a positive 81. That gives you equal to 18. Here we are, right here. Okay? Was it that negative 1 that threw you off? This guy? That catches everybody. Now, divide everybody by 18. So this is going to give you y plus 3 over 2 minus x minus 1 squared over 18 equals 1. And you can go from there. Which one is your major axis, your transversal?
Y.
The y, the one that comes first, the y. So this is your A, this is your B.
And in the ellipse, it would be x.
In an ellipse, if this was a plus, it would have been your x because that one was larger.
Also, in this case, it's just whatever comes first.
This one is whatever comes first. Now the problem with the ellipse is this. If this was an ellipse, it doesn't matter who I put first because I'm adding. So in that case, we use the larger one. But in a subtraction, it matters who comes first when I subtract, right? I don't get the same thing if I swap the terms around. And again, here's your asymptotes. Here's your y plus 3. There's your x minus 1. Your slope is change in y over change in x. Take the denominator of the y, radical 2, denominator of the x, radical 18, and take the square root. And this is easier to put it under 1 and make it the square root of 1/9. Thanks, Alexandra. Is 1/3. See it? If you took this and you did 3 radical 2, that's fine too. What happens to these guys? So it's 1/3. You gotta reduce. Theoretically, you can separate, you can join together the divisions, whatever one works best for you. Okay? Start like this. Now, when you find the equations, start with your sketch, just like you did with the ellipse. And might I remind you, you guys liked doing the ellipse problems, finding the equation. You did. So
It was fun.
yeah, so this should be equally fun.
Okay.
So your vertices are at 0, 2, and 0, -2. What does that tell you?
But it's still be oh,
A y
square.
is coming first.
Yes.
Okay, so we know this part. It's vertical. Yes,
I said that.
you did. It certainly is. It's a vertical transversal. Okay, and can you find me the center? Okay, good. The center is going to be 0, 0. Therefore, can you find me A, the distance from the center to your vertex? 2, Randolph? Okay, you're okay with that? All right, so this represents your A. So now, I'm going to take this out of here. I've got a y squared over 2 squared, which is 4, minus x squared over b equals 1. All I have left to do is find the b. So let me see what else they gave me. They also gave me the foci. The foci is plus 4 minus 4. And you did say that your hyperbola was going like this, so that does make total sense. And the foci gives me which letter? B or C? C. So from the center to my foci, what is C? 4. All I have to do is find B. And actually, I only need B squared. So there's your Pythagorean theorem equation. Okay? So now, plug in your 4 squared, and A squared is 2 squared plus B squared. So we're going to get 16. 12 is equal to B squared. And do I really care what B is? Nope, I just need B squared. So I'm going to take that guy out of there and put a 12 in there. So I get y squared over 4 minus x squared over 12 equals 1.
And do we have to do the asymptotes?
Nope, all I need is the equation. How nice was that?
Also, for the find the asymptotes, we only have to count like one equation for the asymptotes, right? There'll be a plus or minus in front of it.
Yeah, because you actually find them both at the same time
Right,
because we don't distribute anything.
Okay, so
We just leave it like
as
that.
long as the plus and minus for the one equation, we can do the circle.
You okay with that?
Let's do one more.
Okay, let's do one of the asymptote type.
To the back.
No, it's right underneath this one. Okay, so let's start with your vertices. Your vertices are at 1, 0 and at -1, 0. So which is your transversal axis this time?
The Y.
Yes, because it's going to go off your vertices. Doesn't it have to go this way?
Yeah, it's on that.
Yeah. You were doing that too with your hands.
Yeah.
So we've got this format. Okay? Therefore, what's the center? 0. Again, we got lucky on this. Center 0, 0. Okay? What's A? 1. Good. Now, so therefore, let's start. We know 1 minus y squared over b squared equals 1. Okay, so now, we weren't given any foci or any b's, but we were given that our asymptote is this. Now, again, the part that we recognize, we can kind of watch. We can recognize this from here. We can recognize this from here, right? We're good so far. Here's my slope. This is the guy we're going to work with. My slope is my denominator of my y over the denominator of my x.
So 5 over 1.
So my slope is equal to 5 over 1, right? And what is the square root of the denominator in the x?
25.
No, square root of this
One.
side.
Or
1. So I've got the square root of your y denominator over 1. Okay? Now, let me just take the square root out so this doesn't mess you guys up. Let's just say y denominator, because all we really care about is your y denominator, right? And then over your x denominator. I want your y denominator.
25.
Let me leave it like this. All right, so cross multiply.
Square.
So yeah, so if you square both sides, your y denominator is equal to what? 25. Now, let's see if that works for us. B is supposed to be 5, right? So I would be going up 5, down 5. Here is my thing. Here is my line. Is my slope up 5 over 1? Is it matching this? Yes. Good way to look at it. Okay? So when you have an asymptote, work with your slope. That's the part you're going to have to work with. Your
So,
slope of
Are
this.
you saying it has to go?
No, we had to find the slope because this is your ratio of your slope.
yeah, once we get the slope, then she wants to like match the graph looks like that's going to go.
Yeah, well, kind of. No, all you really need to do is make me your equation. I don't really need to see the rest of it, but I just wanted to show you that this would go up 5, down 5. That's where this 5 This 5 is this, 5 squared over there. So that's what I didn't want to make it your y denominator because I wanted just to make it your y, which is really going to be b. If I found your b, then we could square it to get your y denominator. So I decided to go back with the square root sign. But if you wanted to, you could do this. Do this.
Charlotte Parker Johnson, please call the main office. Charlotte Parker Johnson, please call the main office.
Hang on one second.